Peter James, Managing Director of Cintec, is joining me today to speak to us about how Cintec's engineering principles benefit culturally based project initiatives around the world. How does Cintec merge creative thinking and engineering principles to solve client problems globally?
Obviously, we don't sit here and look at blue sky engineering and think, well, what can we design to solve what problem? By and large, they're a matter of connections and really on what your primary discipline is or your trade. And so in our case, it's anchoring and holding structures together. So from very small anchors to hold cavity walls together that we have predominance in the UK, we went on to longer anchors, and some of the anchors that we are installed are probably over 110 feet long. So we didn't just jump into that. It's a matter of experimenting and trialing it. And then you go from strength to strength. You then go from just strengthening structures to looking at structures that have dynamic movements to it, like bridges or impact for walls in it, or blast, and seismic, of course. So you then start developing your tools to meet all the various scenarios. But by and large, half of what you're doing is already covered with what you've done. And so it's only a matter of research and development on the next phase to fit the next problem.
Please describe Cintec's recent operation to save the oldest pyramid in Egypt. Can you please give us an update on the project?
Sure. The problem we had with the pyramid at Saqqara is that we'd already completed one pyramid called the Northern Red Pyramid several years ago, and we also have finished 12 mosques in Cairo over the last 15 years. So we had a pedigree of working in the sort of material that was in Egypt. So having worked in Egypt and had some very good results, we were then asked to look at the step pyramid at Saqqara, aged almost 4,700 years old. And the problem there was that because it was the first pyramid ever built, and it was in the form of steps, 6 steps, totaling about 65 meters in height, it had a flat ceiling in the burial chamber. Now, subsequent pyramids after that didn't have that. They had a technique called corbin, so that the ceiling was in fact a conical shape built by overlapping the stones as you went up as it was built to form a ceiling. But on this particular first pyramid, it had a straight ceiling, and therefore during antiquity and other earthquakes, particularly the one in 1994, it shook the flat ceiling with the timber beams, and it all collapsed, dropping some 29 meters onto the sarcophagus at the bottom. The burial chamber is about 29 meters high and 8 meters square, and the top of it is really level with the ground level, or not much higher. And during the earthquake, the stones collapsed to the natural angle of repose. And can you imagine if you have an inverted cup with jagged stones hanging down? That's what you have. You have a natural arch formed of just rough stone waiting to fall. When we first saw this 4.5 years ago, we photographed it some 29 meters away at the bottom of the shaft, and it looked pretty precarious then, but because of 29 meters above your head, it just looks flat plane. It was only till we eventually got the scaffold in place to about a meter of the arch where it formed on in the dome, did we realize how big the problem was, that the stones were probably 200 or 300 kilograms in weight and just really hanging there waiting to fall. And only the fact that they were just wedged in together stopped them from collapsing. However, the last year or so, several of them have actually fallen, so it was a particularly dangerous job. So we needed a system of how do we secure this so we can safely drill and anchor it back in position and not allow it to collapse. But we have another technology which is called water wall, and water wall is used for the latest IED and blast mitigation, where we've made water freestand up to 3.5, 4 meters tall using a system of stressing a very light fabric so that we create water from continuum to being a natural rigid wall. On some of the appliances we have, we need to have an inner layer to hold it in place, and we use air. And so it was this technique of using air, using highly reinforced fabrics, that gave us the idea of making pillars about 1.5 meters diameter and a meter high to support the ceiling using some dense foam at the top so we can cut in around the rugged rocks so that we can hold these in place. And what we've done, we have the scaffold in place, and we have a system of air that's supporting the entire 8 meters square of roof. That's been accomplished. We've then taken some loose stones that fall on bottom and done some pull-out trials to make sure that the anchor would work in stone and to get some values. And then we looked at the medium of holding it all together by grouting it or pushing grout in between all the rocks so that we stop it from rotating when we start drilling it. And the object of the exercise really is to support it, hold it in place, not allow any forces from down or above to move the stone, while we then carefully use a diamond drilling technique, dry diamond drilling technique, and drill anchors at 90 degrees to the circumference of the dome, about 3 or 4 meters long, to create a bigger area than the 8 meter by 8 meters. Almost like when you get an egg time and you turn it upside down, you can imagine if there's some moisture then it blocks and you have all the particles held above. We're actually trying to make the particles, consolidate the particles bigger than the hole they're dropping in. And equally like a stone arch never sleeps. It's always working for you. And that's what we're doing. So we're creating an arch in 360 degrees and making the area bigger than the 8 meter by 8 meters so it won't fall through. And so when these anchors are in place, we put maybe a stainless steel mesh on the underside as well to stop the small parts falling down, and then we will have a complete repair. The stage we're at the moment is the airbags are in place. We've done the tests on the stone. They prove positive. We've now finalized the grout. We're now waiting for the antiquaries to give us the next go-ahead because obviously there's a new regime in place and they have money issues and various other issues. So we're now waiting for them to say, come back and finish it. There's probably another 2 months' work left in the project.
What are the primary advantages of Cintec's patented anchoring system?
Can you imagine you want to build a house and you want to have a door opening? Above the door opening you would put a lintel, and normally these days it's a concrete lintel. And the way you form the concrete is to put a timber shutter, you put the steel inside, and then you put the concrete inside there to make a lintel. Then you take the formwork away and you have a concrete lintel. Then that goes above the door and it holds all the forces above it. What we have done is used a sock rather than the timber. So when we drill a hole in any material, the sock is designed to expand to a little bit more than the hole that we drilled. Therefore, that acts like a timber formwork. And therefore, we can drill and put into a structure steelwork almost like the lintel, but we're doing it retrospectively. So we're looking at an existing building, we're drilling holes, we're putting a sock with steel inside and then pumping it up like a balloon, only using a very fine micro concrete. And the concrete can be changed to suit the building and the structure we're in, and the steel can be changed to whatever grade we want to carry the load. And because we pump it up, we know that the whole thing is inflated because we pump it from back to front. So the grout goes right to the back and then forms to front. So we know that the grout is in every position around the anchor, all the way down its length, and therefore it's in contact with the material that it wants to pump to. And so there's this idea of being able to transfer the loads from the steel bar that's carrying the load through the grout, past the sock into the repair material, is a unique way that we work.
Thank you so much for taking the time to speak with us today, Peter. For more information, visit Cintec's website at www.cintec.com.